Question A7 then from the 2012 Advanced Higher Applied Maths Mechanics. A little, looks like conservation of energy, and with this little impact, conservation of momentum. Right, what's it got to go? Show these three things. So what does it say? A ball of mass m kilograms is suspended from a fixed point by an inextensible string, a light string, no mass for that, or no significant mass, of length L. It makes an angle of 45 degrees, and when it hits this block, it's travelling at a speed of u meters per second. So the first thing is this, show that u is equal to this expression here. Well, that will be a change of energy, conservation of energy. Pulled up here, it's got some potential energy. When it's released, that potential energy transfers into kinetic energy. So how much potential energy did it have to begin with? Well, the potential energy would be mgh, where h is this difference in height. Maybe we should really have the change in it, delta h, we'll just call it h, where h is this distance here. Well, that means h is going to be the length minus this portion, which is adjacent to the 45, so that's the L cos 45 minus L cos 45. So h is going to be, that's a common factor, 1 minus, and the cos of 45 is 1 upon root 2. So that means the potential energy it had was mgl times 1 minus 1 upon root 2. Now if that changes into the kinetic energy, which will be a half m, and they're calling that u squared, then that kinetic energy came from that potential energy. So that would have to equal mgl 1 minus 1 upon root 2. Now it's just a case of rearrange that. U squared would be, the m's cancel out. We've got gl, that 2, instead of multiplying it here, you could multiply it inside it beneath there. So that would just be gl times, multiplying by the 2 minus, and of course 2 over root 2 leaves a single root 2 on top. And then finally, u will be the square root of that then, the square root of gl times 2 minus root 2. Right, that was that done. Now, what happens after? It then rebounds off of this block with a speed v, having transferred some momentum, and returns to rest with the string makes an angle of 30 degrees. And of course this block, being on a frictionless surface, then moves off with a velocity capital V. Now of course I'm not putting the signs into this, I'm just using the sizes just now. So that's just the reverse situation. The kinetic energy it had to begin with will get transferred into, once it's used up and it comes to a stop, into the potential energy at this part. So what was the kinetic energy? So the kinetic energy would be a half mv squared, as simple as that. And what's the potential energy then by the time it comes to stop and all of that's been used up and transferred into lifting it up there? Well, the potential energy would be mgh. And what is that height that it's going up through, this height here? Well, that'll be the length minus the cosine of 30 times the length. So that would be mg times L minus L cos 30 degrees. That part there being L cos 30 degrees. I'll just mark it in L cos 30 degrees. Just like in the previous one, that portion was L cos 45. So that's going to be mg, L's a common factor, 1 minus, and the cos of 30 is root 3 upon 2. And where did that come from? It came from the kinetic energy, so that equals a half mv, that's meant to be a small v squared, and then just rearrange that as before. So v squared would be, again I'll take that 2 into the bracket, and the m's will cancel, so it'll be gl, and the 2 multiplying the bracket will give me 2 minus root 3, and then finally v is the square root of all of that, gl 2 minus root 3. Now this last part. The block moves to the right with a speed of capital V meters per second. Show that this expression hold V equals km over m root lg, where k is some number, some constant, and state the value of that constant. Well, that takes place in this little impact here. This will be the conservation of momentum. So we've got before and afterwards. So we've got the momentum before. was it came in with a mass of m, and it was a speed of u, and afterwards the momentum, the final momentum, would be then split apart. Now that v is in the opposite direction, so that would be negative mv plus capital M capital V. Momentum before was only the ball that was moving, only the ball had momentum, and that was mu. Afterwards, they're both moving. So conservation of momentum means those two things must be the same. So I'll put it a little bit around. mv minus m small v must be the same as small mu. So mv will be m times, taking that across and adding it, might as well just put u plus v. And finally v would be m over m u plus v. Well, I took a note of u and v there. So that's going to be, the velocity will be small m over big M of, add these two together. Now they've got a common factor of root GL, so I'll put that in, root GL. And then they've got a separate part of, whichever way around you want it, 2 minus root 2 plus 2 minus root 3. So it says, show that v equals this part, but with a k at the front, so that must be k. So v must equal km over m root GL, where k equals this thing, the square root of 2 minus root 2 plus the square root of 2 minus root 3. Well, that's its exact value, but does it want it as a decimal? Well, you could always just do that, just press the buttons in your calculator just for safety. And if you do, you get 1.2830 blah blah blah. So we could round that off to k equals approximately 1.28.